In Python, we have what we call the identity operator. Remember the ID. When I define string 1 as Mustafa, string 2 as str1, string 3 as str2, string 1, string 2, string 3 will all have the same ID in the memory. When I say str1 is str3, the is what we call the identity operator, and it's mainly counting on these IDs. Are they the same IDs or not? So if the two variables are the same in the memory, this is going to return true. So is star1 is star3 is true. Now let's create another class here, employee, and create two different objects. Object 1 would have the variable name Mustafa. Object 2 also have the variable name Mustafa. Object 3 is equal object 2. Now observe that object 1 value is different from object 2 value. You might say, oh, but they have the different values here. However, every time the class employee will be created in a different memory location, this is going to be mutable and you can change its content later. So even Mustafa can be changed to something else. So object 1 and object 2 will have different memory location, but object 2 and 3 will have the same memory location. You can say object 2 is object 1, the answer would be false. So they are different things in memory. Object 2 is object 3, yes. The opposite of is what we call is not. So object 2 is not object 3, the answer is false. So is for the same memory location, is not for the different memory locations. The most practical usage for the is operator is actually checking about the types. For example, you have here x equal 1. You can say if type of x is int. So now we are checking if these two things are really equal. You can also, like, let's say y is none. So you can say is none, is not none, and so on. In a very similar way, you can say if the type of some object is employee. This is the most practical usage for the is in practice, and let's see why you should avoid far from that. Let's define x and y, two different variables. X is value 30 and y is value 15 plus 15. Now x is y should say true or false. We know that x and y are two different objects. We didn't assign them to each other, so they don't have to be true. They actually have to be false. But given that x and y are mutable value, we know that CPython is going to link them to the same value. So what happening in CPython is as following. For a small number of integers and characters, strings, sorry, they actually like attach them to a small namespace so that they can make reuse of them, given that they are mutable. So why to make them different in the memory? So if you wrote x is y, probably this is going to give you true, but it doesn't have to give you true. It actually should be false, but given that we are making some memory optimization, it will give you true, as we learned it before. Now let's use x and y here, but multiplying them with something very big value. Again, x and y aren't the same things in the memory originally, and CPython doesn't store in its cache something for such a very big values. Probably this statement would be false. Okay, so be careful, like from probably true and probably false here. The same idea exactly for strings. If you define the small strings like hello, hello, x and y aren't equal, so originally they should be false, like they shouldn't be linked to the same memory location. But we know that if we define hello in the memory and it isn't going to be changed, so why not linking both of them together? So x is y is yes, true. Now if you decided to make something like a very big string, CPython will not cache them in its namespace, so probably a huge statement will be false. But notice that not even every small string is true. If you just add something like the not here, this mark, probably this is going to give you false, because part of their cache for the strings doesn't involve the such a mark. It just involves letters and the digits and underscores. So what must be true really? If you said something like z equal x, then x is z must be true. But be careful about that. Small values, small immutable values might be true. Big immutable values will be false. Now, as you see, no one should count on that in the memory, like it isn't our business. And this takes us to something else. The difference between is and equal. If you said here x comma y was two big same value, if you said x equal y, it will be true, because we are now comparing value by value. We are comparing the content itself. So x equal y is true for content. If you try to say x is y, it will be false. So observe, they have the same value, but they are false in the memory. In a very similar way, if we have two small values, the equality will be true, and is will be true also. As you see, this part is very implementation dependent. So the advice here is use only the is operator with the type checking that we learned. And when you want to compare value by value, do not use the is operator, use the equal. So equal for comparing content by content. And use the is mainly to check the type. Avoid using is with immutable objects, because it might be very confusing. Is operator is fine with immutable objects, with mutable objects it's going to always work well, but with immutable objects it's very tricky for this probably false and probably true cases. That's all.